Oh my gosh. Oh no, it's after this. 8.2.
I actually don't have alerts, but it's.
All right. So 46, yeah, because there's no solution for this one either, because it's an even number. So 46, according to a recent study by the Annenberg Foundation, only 36% of adults in the U.S. can name all 3 branches of government. Holy crap, that's embarrassing.
Yeah.
Like, that hurts me at my core. This was based on a survey given to a random sample of 1,416 U.S. adults. And so I'm not going to go through every step. Was this the one?
No.
Just kidding. Oh.
Sorry.
I remember that.
It was one thing. It gave me like a percent, and then I needed to find a percent of that percent or something.
Let's.
Let me.
Yeah. Why
I'll
don't
ask
you
you
try to?
later.
Okay. Yeah. I was saying, why don't we say a little bit during into advisory, and then we can go over them.
I have to go to science for the science video.
Yeah, it was the last.
Like.
Okay.
Look for it. I was saying, look for it before Monday, and we'll
I will.
address it then. And guys, yeah, don't forget, you can ask questions from any point about the homework questions to build up the understanding. So again, I forgot to mention this, and we had way too few students for me to hold y'all to this today, but on the day of demonstrated understandings from now on is when I'm going to collect FAIR models. The design behind that, or that change, is I want to be able to give you insight on the FAIR model before you get to the test. And on top of that, that way you have a little bit less to do at a time, right? So you're not waiting until the test to do it all. The FAIR model up to this point, well, before this point, on the day of the demonstrated understanding, which some of us still have not taken that, we need to make that up. We had not done the last 2 sections about 2 variable confidence intervals, so you didn't have to have that done. I would like this FAIR model submitted today, but I will give you until Monday to get the FAIR model done. If you wait till Monday, you need to have the entire FAIR model done for confidence intervals.
The
Yes.
one that we just got.
Yes, on Monday. The one for confidence intervals of 2 variable, which is just the first page. I think I gave you 2 pages worth of FAIR models, right? So it's just the first page of confidence intervals. And that'll be due Monday if you don't have it today. I didn't check, but I'm going to go out on a limb and say most of us forgot that there was technically a progress check due last night. 1,000% right. So, hey guys, listen, again, there was a lot going on yesterday. I'm going to be gracious with y'all. Get it done by this weekend. The one bad news about that is there will be a second progress check, or there is a second progress check that's on 2 variable confidence intervals. And so I need that done. I'll give you until Monday to get that one done, but just be aware, like, they start stacking up. So the whole thing is, I would do my FAIR models, I would then do my progress checks to help me check to see that I know how to apply that information well, and then from there, you should hopefully be ready for those demonstrate your understandings.
So can we take calculators over the weekend to do that?
Yes, you may take a calculator over the weekend to do that. Hey, quick note though, just because I need to keep track of my calculators better. If you borrow a calculator, I need you to take the hat off of it on the top moving forward, just so I know how many I have out. And 2, my first block is a little bit larger of a class, so if you have calculus, please drop that calculator off to me before you go to calculus, because I know she has her own set of calculators, but that way I would have enough for all of my calculus, or my stats too. Algebra 2 students. Yeah. Yep. All right, Mr. Arliss, you ready? As ready as we'll ever be, right?
Yeah. Alright, so let's look at how inference for experiments is different from inference for sampling. What do we think? important about experiments? What do experiments do?
Give a cause and effect.
Cause and effect. So think about our inferences with that compared to what. Okay, what did you say we should have run instead of sampling?
It's fine to say sampling, but usually when we say sampling, we really mean, like, with random sampling,
Is that like an observation study?
so a lot of like the observational study. Now remember, you can have random sampling with an experiment, right?
Yeah.
And so it's more about that random sampling, and you have to be careful about that because what's one of the conditions for a confidence interval? Randomness, right? Random sampling. But with an experiment, do you necessarily have random sampling? No. And so it's going to slightly change the way we interpret because we are still having random, it's just random assignment. Sorry, let me find, what pages was that in the book?
570, 573.
So it says a little bit above there. Right? Yeah, so we've done data produced by random sampling, but randomized comparative experiments is a big deal. And so pay attention to this. Read through that information just really quickly. Tyler, have you read through that information on the board?
So for a confidence interval for an experiment, you have to check if there's random assignment.
You will need to check randomness still, random assignment. That's the random that is involved in experiments.
Okay. What exactly am I supposed to be looking for? Or we just read?
The idea of how do we interpret, what's the difference in interpreting experiments versus when we have random sampling?
Okay.
So what key do we see, guys?
I'm thinking it lies in the word would.
With experiments, you're trying to
Like
describe a
would.
causative link, I suppose. You
So-
just have to keep that in the interpretation of it.
Okay, so causative link, something about that. There's another key detail. I might look at, I don't know, maybe that AP exam tip?
It specifies that as the parameter.
But specify the parameters of what else I got in there?
You need to describe the true proportion instead of the sample proportion.
Okay, keep reading. So what's the issue? What did students regularly screw up when they talk about the true proportion of the men who what?
Who had?
Had surgery? If you have had surgery, are you a part of the population or are you a part of the sample? You're part of the sample because you had the surgery. You're part of that study, right? And Ashton, what did you say is probably a key word there?
Would.
Would, right? It is still a predictive thing, so we have to be careful about that who would survive when getting surgery or being observed. Okay? So make whatever notes you need to help you remember how to interpret that confidence interval for experiments.
So what inference can we make with experiments? What can we infer?
About the sample proportion? Or is it the true proportion?
Basically, like, it's more predictive than it is, like, you're not,
It's predictive about what?
like, it's predictive about the proportion, so it's like,
Of the people who are like the sample.
Yeah,
So, is it predictive about a population?
Not necessarily.
Not necessarily, right? Remember, an inference for experiments, probably not about the population, but it is about people like those in the study, but you're still making an inference about what?
the true proportion of people like those in the story.
Okay, you're still missing something, it's an experiment.
Positive,
Yeah, right? It's still some type of interpretation about cause and effect, right? Just not about a population. I will point this out. Why do you think we're only seeing this question about experiments now in 2 sample confidence intervals, and we didn't see this earlier with 1 sample?
You need 2 treatments.
Don't you need at least 2 treatments for an experiment?
Yeah.
So are we gonna do confidence intervals for experiments with 1 sample? No, right? So keep that in mind, those confidence intervals for experiments are only with 2 samples.
How would you word this?
I'm trying to write it down.
Yeah, that's fair. Peyton, have you written any of this down? Where are your notes, dude?
Sorry. I was just trying to pay attention to that.
No, you ain't. You're writing notes to Haley.
I do both.
No, you ain't.
Like,
Multitasking.
No, you ain't.
skill interpretation.
You ain't written a single thing down.
All of this sass on a Friday morning.
It's all this sass because I care about you and your future, and you're sitting there writing notes instead of these notes. And we got something to learn. So experiments, how is inference for experiments different? Experiments about cause, about cause and effect. So not talking about a population. So when we interpret, 2 things, right? 1, it needs to be about people like those in the study. The interpretation needs to include that detail of like those in the study, because it's not about the population. And 2, we're looking at a difference in the treatments. That's the cause and effect. Right? So, that interpretation needs to be about people like those in the study, and it needs to be about a difference in treatment proportions to see how effective it was. Yeah, I just wouldn't include the sampling detail, this would have been, that sampling just, again, the true proportion from the population, right?
Someone's asking us, can we use our calculator to solve this do step? Can we?
Yeah.
So what do we do with our calculator?
Like at that point,
Oh,
that'd be a 2 proportional.
Sorry.
Still talking about
did
experiments.
we do the 4-step process yesterday for the first time?
No.
Or was that on,
That was on Wednesday.
that was on
Oh,
Wednesday?
yeah,
that was
yeah,
yours.
Yeah.
yeah.
So remember, 4-step process for an inference procedure, you always need to talk about what 4 things? State,
Do.
plan, do, and conclude. Okay? So you need that 4-step process.
What were the drawbacks with the calculator again?
Well, the drawbacks are if you type something in wrong and all you did was the calculator, then you don't get any credit. So what did I recommend you do?
But
Write out that formula first, right? Write everything in the formula out, the general formula, the specific formula, and then type it into the calculator.
So you get partial credit if you get it wrong, but you wrote all that stuff down.
Yeah, so like if you type it in the calculator wrong, but you wrote everything out right, then they may even sometimes give you essentially correct because you clearly showed that you knew what you were doing, right? You just put something into the calculator wrong. So that's what I would do, right? I would write out the general formula, I'd write out my specific formula and use that
You go
to,
over with the general and specific formulas already.
Look at your formula sheet.
Okay, there's a lot of things on the formula sheet.
Okay, but on the actual AP exam, I'm not gonna be there to tell you what the formulas are. So
I'd
I
much rather
want
learn
you
now.
to look through there and find the general and figure out what the specific formula would be. Yes,
Thank God, 'cause I was-
that's why I'm letting you use it this whole time and I keep pointing it to you.
I think you should go.
Whatever.
Somebody else help Deacon out. Where do we see the general formula? Come on, all of you need to be able to find it. The general formula for a confidence interval, guys.
Oh, that. See, that's what I was asking. For what?
My guy, what are we studying? My guy.
It's Friday. Okay, it's Friday.
You go to a Powder Puff game and forget everything we've
You're
ever
right.
studied.
You're 100%
That was
right.
barely.
Do we need to write it out now, or are you good?
No, I'm good.
You sure? Does anybody else want us to write it out so that you can see it? It's okay. But I do want to see the formulas.
Yeah.
Is it good? Alright?
So you wanted
Yeah. Perfect.
Conclude.
to, if you guys work together a vertical surface on, this problem.
Before you do that. Oh, I like to complain about things too.
Ooh, random groups.
Yes, sir. Yes.
I don't like
I know, it must be tough to like talk to new people and make
No,
sure
it's
everyone
not
can
know
tough.
everybody.
Yeah, we
People
know
don't like
everyone.
talking to me because I'm mean.
Oh, Aaliyah. We're gonna help people learn to talk to you. Who else is missing on this?
I don't know, talking to me is like a special talent.
Same with you.
Talking to you is not.
Oh, okay, I'm good.
That was actually like.
I'm okay.
Let's go.
We're all looking at each other, guys.
Alright, group 1 here, group 2 here, group 3, and group 4.
That's
We
it.
all have to like your
Or if group 3, you can also use the TV.
I would never rate.
Yeah, the TV.
Where did you take it? It's just a CD.
Huh?
Where
Up here. Deacon, you're up here with Josh and Joseph.
Where is, Mr. Kenny, where's your holy chalk that you prayed?
What are you even looking at?
No, you don't get that, it's just from Matthew.
We're basically that.
I'm going to go and buy some.
Good luck.
We're agreeing.
Is it really expensive? Is it good, it's good chalk?
So we're working on this project.
Do you have blue chalk? No. You got white chalk.
Low income families.
It's not just blue chalk. That thing writes beautifully.
Try that one.
It's a little bit glides better. It's soft. Okay,
But Peyton, let's focus on the math.
Yeah, that's good.
yeah, you're right, you're right. Third one.
Likes to get up in there and get involved. Things you guys state down. Right plan. You don't have to do this, but I highly recommend with the plan, your plan starts with what you're trying to do. Well, we're trying to do a confidence interval, plus or minus my critical value, times my standard error. And because I've already defined it up here in my state, by the way, I pointed this out to Deacon, I've never thought about this, but I highly recommend thinking in the terms of this language. When you start an essay for English, what do you always start with? A thesis. That thesis tells what you're about to prove, right? This is your thesis. Tell them what you're about to prove and how you're going to get there, right? We're doing a confidence interval, a 95% confidence interval. And I do like that someone's made the note 2 proportion Z interval for what? The true difference in proportions of children who would attend pre-K and need social services compared to those who would not attend pre-K. And I think that's where I put my would in there, who would attend and who would not attend and need social services. That's my state. My plan then is going to have my general formula, because that's going to help me remember, hey, I just talked about I need the difference in these proportions. And I did point out to this group over here, once I talk about the true difference in proportions, one, I need more context here, but I think I wrote it over here, right? When we get to the end of this first context, the true difference of proportions of children who attended pre-K and who would attend pre-K and need social services, I wrote P1 here. And then compared to those who did not attend pre-K and who would not attend pre-K and need social services, I named that P2. That way it's clear when I do P1 hat minus P2 hat, I know what order I'm doing it in, right? You need to clarify what that true proportion is when you got two of them, okay? Last detail with that. Oh, so P1 hat minus P2 hat plus or minus Z times, and this is where I go to that formula sheet because it's a beast of a formula, but it's right there. There's my standard error. It's one of those things that only time with it will help you remember it. And then this tells you what conditions to check. For this to be a good estimate, what do we have to have? We have to have a random sample. Or in this case, random what? Assignment, right? We have to have random assignment for an experiment. To be able to use Z, Z is based on a normal distribution, so we need to check what? Large counts. Isn't large counts all about normality?
Yeah.
And then to use standard error, I gotta check my 10% condition. So this is why I write my formula out here. It tells me which conditions to check, right? And then I have it ready to substitute into later. And quit making your life hard. Don't get the decimal. Just leave it as a fraction. Right? You're not having to plug this into the calculator except where it asks for the, where you go to 2 proportion Z interval. And what do they want in the 2 proportion Z interval? Do they want the proportion or do they want the counts? They want the count. So don't make your life harder than it has to be. Did you get all that while you were writing out with an octopus and some word over there? Were you spelling my name? You know you spelled it wrong, right? There's not a second E.
I knew that.
Uh-huh. Alright, so
Wow.
write this information out into your notes. If you need to get an extra sheet of paper to write it out to have an example, do that. Make those updates, those edits quickly and efficiently. I want you to have some notes, and then we're going to talk about B. And Mr. Arliss will talk about B.
Kennerman graffiti.
Hey, don't forget guys, we just need to get this in our notes at this point.
Just leave it. It's over.
You better run like the wind bullseye, come back and write that problem out.
Which man was all?
Yeah,
Huh?
I was asked, could I go?
Hold on one second.
I did that like last week and I'm just waiting to see my face. Mayor and Direction as well.
Have you written any of this down yet?
No.
Okay, write this down, and when she comes back, you can go.
Mr. Kenny, let him have it.
What's your question? Well, first off, you're not doing a 2 sample.
Oh, I'm not
using interval.
That was my experiment.
Generalized for the future.
That would be what you're saying.
You
should pick the right one.
5, I think. Not just people who are
Six.
done.
Alright, makes a lot of sense.
Doesn't it?
Because you're not gaining.
This guy is the right interval. I was gonna write it down.
So that's the right one if you do it in,
Hey, you have to.
if you do it the reverse order.
No, but you should.
So that should, yeah, it'll tell us the same information. Yeah, notice these are all, oh yeah, so y'all got the positive one as well. But these are the negative ones. So you can have positive or negative. 95% confidence the true difference in the proportion of students who would need social services after not having pre-K and students who would need it after is, so there's one detail. and this is something I need to talk about based on what I saw yesterday.
Okay,
Oh, wait,
It's not between this, it's captured by this. Because, here's the reason why, is, and it's, they're nitpicky on this
I
language,
just put it on my hand.
is when you say it's between these two values, you're saying that the interval is correct, and that the true proportion is moving around. That it has the ability to move around. What we're saying is, we think this interval is capturing that parameter, rather than, hey, it's just in between these two values. It's goofy, I know, it feels like it should say the same thing, and it took me a long time to wrap my brain around it. Just be aware, we're saying that we think that this interval is capturing that proportion. Which is why also in the book, they actually have that interval first. I am used to writing it second, so you see me write it second a lot, but in the book, it has the interval first. And so this interval captures the true proportion of blah, blah, blah. Okay, that's what I would do there. Oh, hey, have you written it down in your notes so that you have this for the future reference?
But I'm almost done.
But we gotta get going.
Jeez.
Guys, there's a certain level where we gotta move. Plus, y'all want skills today. That's what I heard.
You're right.
So we gotta get going.
Wait, Skittles?
Yeah.
I can't have Skittles.
Well, you don't get to have Skittles, but everyone else does.
Dang.
We should do M&M's.
We will do M&Ms when we get to two proportion Z test.
And what can you
Z
have?
test.
I can't have any sweets until Easter.
After we get king size.
Can't have fun, I guess.
Well, it's a religion thing.
Alright, so based off of this interval, is there
What?
convincing evidence that the treatments weren't equally effective?
Yeah,
So why? What tells us that?
because there's no option for 0 to be there.
Right? Because when we go from, we got two positive numbers right here, right? So 0 is not within that interval, so they can never be the same. So there's always going to be a difference, or there's convincing evidence that there will be a difference every time.
I would say, is there still a possibility that they could be the same in B0? Yes, but with 95% confidence, they're not the same, right? And I will point out, some of us got negative versions of it, -3 or negative 0.3479 to negative 0.327. Why did some of us get a negative and some of us got a positive?
Because they subtracted, like, in a different order.
Yeah, you just do it, you defined P1 and P2 differently, but that's why in your state and in your conclusion, you make it clear which one went first. Okay? And that's why over here, I put the P1 after that detail about the children who would attend pre-K and need social services. Right? I put that P1 after it for that reason. So, yep.
Anyone want to add before we move on? Mr. Kenny?
Not add, but definitely make sure you take a picture of that and update your notes completely. I want you to have a complete example. So maybe take multiple pictures and pull the best together, because we have very close elements. Oh, there was one last thing. Sorry, I almost forgot. Last detail is this. So right here, this is a common thing I saw yesterday on the demonstrator understanding, is this language that with 95% confidence, the true proportion is between 0.327 and 0.3474. Do not use this language, because what that language indicates, and they're very particular about this on the AP exam, is that language indicates that we have this interval and the true proportion could move around, but the true proportion is the true proportion. It's fixed, right? So we're hoping that that interval does what to the true proportion? Captures it. So be intentional with that language of it is captured by this interval. It is not between those values, it is captured by that interval, indicating that the interval can move around, right? We saw it in the applet that depending on the statistics we get, that confidence interval moves around, and sometimes the confidence interval captures the parameter, sometimes it does not. But 95% of the time in the long run, a 95% interval will capture. And so we're confident that it is capturing. Yes,
May I go now?
yes.
If you think about it, with enough 95% confidence intervals, there's gotta be like a whole bunch that are like just incorrect.
Yep.
Alright, so this is your homework.
Associated with it, yeah.
Yeah. Page 574.
Remember, these are practice problems, not multiple choice like the AP Classroom. The AP Classroom is great multiple choice because it's like the AP exam, it's like what you'll see on your demonstrating understandings, but you also need free response practice. That's where these questions come up, right? You don't have to do all of them, do a couple, check yourself. If you're rocking it after 2, then chill.
Alright, this will, you guys have this is gonna be like a good note sheet to refer to. So if you guys fill this out right now, or are you gonna do this for?
I was gonna say do that for homework just because it'll save us time. And have we talked about the names for these intervals? Yes. Have we talked about and looked at the calculator commands?
Yeah.
Yes. Have we talked about the conditions? And have we talked about the formulas themselves?
Yeah.
Okay, just fill that in from there, okay? I will say, you know how we did that one AP free response yesterday? There's a second one on the back side. Do that as well.
How much homework do we have?
So, I am going to direct instruction go over the AP free response on Monday, or Mr. Arliss will, one of us two. And this shouldn't take more than 5 minutes. Just filling out this chart. And then an AP progress check. That has to be done this weekend, one that I'll be doing Monday.
Alright, Miss Kay, you wanna take this one?
Yes. When did the 1 in, oh yeah. Y'all remember the 1 in 6 wins activity that we did? Yeah, what was the situation?
They were buying sodas.
They were buying sodas, right? The company claimed what? That 1 in 6 of the sodas would win. And what was the evidence that caused us to start to doubt them? Yeah, they bought a bunch of bottles from the store, right? How many bottles did they buy?
36?
How many?
36?
Not 36.
32?
Not 32.
31?
Eight.
Looks like 28.
I
20?
thought it was 30.
30?
30. They bought 30, okay? So remember, that's what this is right here, right? They bought 30. So the question was, and how many winners did they have?
6? 3?
So they had 3 winners, right? And that's only 1/10, that's not 1/6. So did we start to doubt their claims?
Yes.
Heck yeah, we did. We're like, man, go bogus. But we did a simulation. Remember when we did the simulation, right? We did random number generator. That's what a simulation does, is it's a chance experiment, and we randomly generated numbers to find out, hey, what's the likelihood of getting only 3 winners out of 30 when they claim that the true proportion is 1/6. And so, notice how we did this early on, and we checked the what? The large counts, right? The expected successes and failures for normality, and it actually wasn't perfectly normal. And so that was problematic, but it's okay. When we did this, how many trials only got 3 winners or less from n equals 30? 8 out of 45. So some of those dots obviously have fallen off. We did 45 sets of trials. 8 of them, right, got 3 or fewer winners. Does anyone remember what we called that 8 out of 45? That was our p-value. Remember, the probability of getting this statistic or a more extreme statistic, that's our p-value. And so we doubted them. But was that enough evidence to say, yeah, they lied to us? No, right? It still could happen 17, 18% of the time. Well, on the AP exam, so what was the evidence that the soda company is exaggerating its number of winning bottles? Not yet.
8.
What happened at the beginning? What made us start to doubt them?
Only 3 of them.
All right, only 3 of 30 won. That made us start to doubt them, right? They claimed this. What are we starting to think though? This is chapter 9. If you should have the chapter 9 notes out, page 1. So 9.1 significance test, right? Oh, I must have changed those notes after not printed the corrected notes out.
I've got, we just had this. Yeah, we just had this in
No,
there.
you have chapter 9 notes after that.
Yeah, I have this.
Does it talk about Mr. Tabor, or does it talk about the 1 and 6?
The 1 and 6 wins.
Okay, so some of us got the,
Yeah, I got something about Mr. Tabor.
Well, mine are Yeah, the I got new Mr. one. Tabor. You
okay,
reprinted mine.
hold on. Stay calm, everybody chill, I got this.
I was just saying.
Alright, chapter 9 notes. Yeah, there we go, alright. Alright, so who does not have this first page of notes, the correct first page of notes? 1, 2, 3, 4, 5, 6, 7. Clayton, have you checked if you have the correct page?
I don't.
The correct one is the one about the sodas.
No.
So if you're
Alright.
using Mr. Tabor.
Listen, we're just gonna do the first page right now, we'll make copies today, don't let me forget to pass them out later, okay?
What?
So,
So I'm not gonna be able to write anything?
no, he's printing them right, I'm printing them right now, I'm just doing the first page right now though, because that's all you need right now. Okay.
So what do you do with this other?
So can I just throw away this package?
Trash it, no, not the whole package, just first page for now.
Go ahead and the whole package off.
You're wrong. Mine's state.
That's first, I can't print out the right package.
Oh,
Staple the new name.
Oh, just like Kentucky?
Actually, Kentucky didn't do that all.
Just like Kentucky.
Just like my bracket, so.
Mine busts a Game Boy, okay?
Actually, everybody did.
Alright,
Perfect bracket, so it's not.
Mr. Arliss, can you hole punch those before you go to them? Alright. So, when we did the 1 and 6 wins activity, that soda company claimed that 1 and 6 wins purchasers would win some kind of prize, right? But those 30 students who went to the store, only 3 won a prize, so what's the evidence that they exaggerated its number of winning bottles? Well, not the p-value. So the evidence that they exaggerated, what was the evidence that we're like, I doubt them?
The win rate was 10%.
The win rate was only 10%, only 3 out of the 30 won a prize, right? That was the evidence that started us doubting them, right? That's the p-value, that's the evidence where we're gonna either make a decision or not, right? This is what started us disbelieving their claim. Remember how we did the case of Joy Milne at the beginning of the year, right? And how many of those 12 shirts did she get correct? She originally got 11, and then we found out that the last person actually ended up developing Parkinson's, right? So she got 12 out of 12, and we looked at it, hey, what was the likelihood that by guessing she got all 12 right?
Like 1 in 10,000.
Yeah, it was like 1 in 10,000, right? That was pretty convincing evidence, okay? So,
I feel like I can do that.
yeah, totally. Except we tried that.
Okay, we need one more.
One more? Okay. So, here's what I want to ask, and this is what I need you to pay attention to before we move into this. First off, we already tested it, right? What are the 3 explanations, or what is an explanation for why the sample proportion was less than 1/6?
Sampling variability.
So 1, right? Could it just be sampling variability? Is there a possibility that random chance caused that sample to be less than what was claimed?
Yes.
Sampling variability. Okay? Why else could our sample have been less than that 1/6 actually?
The sample size was one.
So, well, that would tie into the sampling variability, right? When we do a larger size, it's going to reduce our standard error, right? Or standard deviation. but that still applies or tackles the idea of sampling variability. Come on guys, why else, like what else could it have been?
They were lying about it.
They were lying about it, right? That's one option. And so Josh, I'm gonna talk about what you said in a second, but yeah, the company lied. They wanted to save some money, they didn't want to give away prizes. Okay? So either sampling variability or the company lied, or Josh actually hit on a third one that's important. What could it have been, Josh?
Bias.
Bias. I mean, how many convenience stores did they actually go to? How many places did they buy that soda from? So could that have been a biased sample?
Yes.
Okay, right? So those are big things to notice here. So bias because one store. Now, reasonably, I'll say it this way, what type of sampling could we consider that convenience store so that it might not be biased?
Cluster?
Could that be considered a cluster? In a way, right? Like, we believe that one store is heterogeneous and representative of the population. We could say that, right?
It's like convenience bias there.
It still could be convenience bias, 100%, right? I'm just saying, and I will say to be truly a cluster sample, we would have to randomly select the store and then sample everything in the store. But that is something where we could say, hey, I think this one store is representative of the
So
population.
essentially convenience store convenience bias.
That's it. All right, so how can we decide which of the explanations is more plausible? Well, we did one of them already.
Yeah.
What was that called? Not yet. How did we get our p-value? That's the process. What do? We created a...
Simulation.
We did a simulation. Okay, simulation. To find likelihood of getting... And so here's something that I've actually not seen before and not done before, but this I think can help this make sense. So this is the likelihood of getting p hat equal to 3 out of 30 given p actually equaled what? 1/6, right? That's what we're testing, right? We are testing what is, and really not even equal to, less than or equal to. What is the probability of getting that extreme a value, or more extreme, so less in this case, given that our assumption was true? We did a simulation to find that likelihood. Anybody know a problem with doing a simulation like this all the time? It's more what? It's time consuming, guys. It'd be nice if there was a way to do it without having to do a full simulation. In fact, like doing all of it together with all of you, I think it took still 10-15 minutes collecting all that data, right? And that wasn't even that much data. We only did 45 trials. I think each of us did 3 samples is what it was. I think because Mr. Arliss and I got involved, right? So that took time, didn't it? So anybody have a guess as to what we could do based on the units that we have studied now to find that likelihood, to find that probability?
Confidence
You guys have one person needs the interval.
So we could do a confidence interval. We 100% could, right? To see if we capture that parameter, right? And if we capture that parameter, that is some evidence, right? Or that is not evidence against them. But let's learn a new way. So this is what the last one is here. Besides using a simulation, besides using confidence interval, so guys, you can use a confidence interval here, but here's the better way, the easier way at least. How would I find the probability that p hat is less than or equal to 3 out of 30? What have you learned that would help me calculate that probability?
Do we just use like the normal curve?
That's a good question. Could we use a normal curve to find that probability? As long as we satisfy what condition? I gotta use the large count. So this one technically did not satisfy the large counts. Okay, but let's look at these things. So what we want to know, and we're gonna go into a lot of details on this later, but we want to know what is the probability that our p hat is less than or equal to 330. So what would I need to do to, I don't know, put it on a normal curve? Say that again, Austin. I need a z-score. Remember early on when y'all fought me on converting to a z-score because it's like, oh, Mr. Kenny, I could just put the actual mean and actual standard deviation in there. Yeah, you could, but you can't here. Okay? So I need you to convert to a z-score. The AP exam is going to look for you to convert to a z-score. And so what I'm looking for is the probability that z is less than or equal to, well, how am I going to calculate this z-score?
What's the formula?
There is a formula. What is that formula?
Value minus mean over
Minus
standard.
mean divided by distribution.
Okay. Look at your formula sheet. Does anyone see anything there?
It's for the standardized.
Oh shoot, it's right here. Sampling distributions and inferential statistics. What do they write for the value?
Statistic.
The statistic minus the mean, my parameter.
Over standard error of the statistic.
Standard error.
Does it say just standard error?
Of this.
Oh, yeah, of the statistic.
Okay. Okay. So, using and thinking about symbols, what's my statistic? Notice the symbols here. What is it? P hat, right? What's the symbol for my parameter?
P.
P. Divided by
Yes, so,
S of P hat. So what are we going to write for S of P hat?
that's singular. That's
You already know.
P hat, that's one minus P hat
Say again.
of, the square root of P hat times one minus P hat. And
all that.
Have we looked at that standard error formula up to this point?
Yes.
Okay. And so there's two things I need you to pay attention to, and we need to note that are a little bit different this time around. Okay? So first off, I want you to know, do we actually know the true proportion here? No. But what have we done? We have, not yet.
like a mid scenario of, like giving.
Equation.
Don't we have an assumption?
Yeah.
Hey, in science classes, what do we call our assumptions? Remember when we talked about our hypotheses in the past? So my assumption, my null hypothesis, was that P was 1/6. So what's my P hat here going to be? What's my statistic?
3 over 30.
3 out of 30 or 1/10. You can write it either way. Okay. Now I would write it as 3 out of 30. I'll show you why in a second. 3 out of 30 minus 1/6 divided by. Now here's what I want you to pay attention. Why do we use P hat here? What was it always P hat for that standard error?
Yeah. For standard error.
What about for standard deviation?
No.
What was it for standard deviation? Just P. So why did we switch to P hat? Because we didn't know a true proportion, and we still don't know a true proportion, but don't we have an assumed true proportion?
Yeah.
So and this is what you need to pay attention to with hypothesis testing, because you have an assumed P, you're going to use that. So we have an assumed P for the null hypothesis. So you're going to use that with your hypothesis testing. That is the one big difference with confidence intervals versus hypothesis test. You have an assumed null hypothesis, use that P instead of P hat. So what's the square root of?
1/6 times 5/6. Divided by 30.
Are they always gonna give you the assumed,
You cannot run a hypothesis test unless you have an assumption. Does that answer your question? Yep. If you don't have an assumption, you would have to do a confidence interval. Okay. Notice how I just left it all like this. Any guesses why?
Calculator.
Cause I'm gonna plug it into the calculator, I ain't doing all that work by hand, fuck that. What? That?
Oh, okay.
What you think I said?
Bad word.
Man, look at y'all just assuming things.
I
I would totally record that in class.
I believe you.
Am I recording? Good, okay, whew. I started to get worried that I wasn't recording for those who weren't here. Alright,
I can edit it a little.
okay, you can edit it. Alright, so, I need you to pick up that calculator, even if you're not quite done writing it out. I want to make sure that we all know how to type this into the calculator. So what's the button that lets me do cool crap? Menu, where are you going to go from menu? Statistics, where from statistics? Look again. What's number 7? Stat test. Remember, we're not doing a confidence interval anymore. We're doing a hypothesis test. Close. A 1 proportion z-test, right? There's a 1 proportion z-test. And so this is why it's important to do the state early on. So what is our null hypothesis? What can we type there? Notice how it says H0 for null hypothesis. What was our assumed hypothesis? 1/6. So literally just type out 1 divided by 6.
Wait, where we at?
What?
It says P0.
Oh, that's null hypothesis, yeah. That 0 means null, right? So P naught, V naught, H naught, right? Initial height, initial velocity, stuff like that. So put the 1/6 in there. How many successes did we have? 3. What was our sample size?
30.
Nope, just put successes there. Yep, just the 3. N is 30. Now look at the last little piece.
Wait, where did you put 1/6?
That's your null. Sorry, you went to interval.
Oh yeah, I did interval also.
Yep, don't put interval, guys. We're on a hypothesis test, a stat test nowadays, and a 1 proportion z-test, number 5. So the null hypothesis is at 1/6. Successes are 3. N is 30. Now, here's one thing I need you to pay attention to, because we're going to have to talk about that last box in a second, more in a second. So what was my assumed, so I'm going to draw a normal curve every time the AP exam wants to see it. What is my mean here?
1/6.
1/6, right? Remember, I'm going to use that true proportion. That's what I'm assuming is true. And so I got this statistic of 3/30ths. And what I want to know is what's the probability of getting that value. But hold on, let's think about this. What's the probability of getting exactly 3 out of 30? Essentially 0 if we're talking about a continuous curve, right? So it's not the probability of getting p hat equals 3 out of 30, but 3 out of 30 or more extreme. That's why it's less than up here. So look at that last box and click on it. Because notice how it says not equal to? We're going to talk about that soon. We don't want not equal to. What do we want?
Less than.
Less than. So click the last one. Okay? It's because you had this A, Z in there first. Or A first, I think. So guys, what was our p-value in this case? 0.1.
Oh, 0.16.
No, you did greater than. Because we want it to be less than. So run it back through. Alright, so hey, what was that p-value again? 0.16. You mean kind of close to this 0.177 we got by running a simulation?
Yeah, pretty close.
Yeah, pretty darn close, right? When you get comfortable with doing a hypothesis test, is that going to take less time than a simulation?
Yeah.
Yeah. And so that's what we want to notice is, hey, yeah, you can do that simulation, but what's easier?
That right there.
That right there, right? So we got to get comfortable. We got stuff we got to learn out of it. Mr. Arliss, why don't you just go through the next couple slides and we'll just have to do skills on Monday. Sorry, guys. Now you got to show up on Monday. It looks like I got you again.
I'm set on Monday.
You ain't gonna miss those Skittles.
You're right. Well, I could just buy my own skills.
You can, if you want to go to those page numbers, so that we can look at the null and alternative hypothesis stuff. So guys, pay attention to this under draw board PDF. There it is. Oh, you'll need chapter 9, sorry, don't do that.
Skills.
What was it, page? 584. So, they're up here.
Yeah.
It's a sad song.
You ever had those like nerd classes?
Those are so,
Actually, like, thank you.
What next?
so that dude.
Who cares? Who cares? If you wanna get 180, you gotta get this.
Just, getting curious. That was detailed.
Just because I always work
They're so good, bro.
Have you guys read through this little section real quick?
That's about losing, that's about like a relationship. I didn't even know that. I thought that song was about like.
Ashton. My guy.
How do you feel about that album last year?
Future.
Deacon.
And so when do we think we're using significance tests?
When we're using,
When we're testing our hypothesis. And if we're not testing hypothesis, what are we doing?
not testing hypothesis.
We're not testing it, so what are we doing?
Confidence interval.
We're trying to find that confidence interval.
And notice, guys, that hypothesis starts with a claim. Someone claims something to be true, and we what?
Tested it, disprove it.
Not necessarily disprove it, but we at least doubt it, don't we?
Yeah.
There's something we're going to talk about thematically soon. The way that people always equate this in the AP stats world or in statistics in general is think about a trial, right? You're what until proven guilty? You're innocent,
No.
supposed to be. I said
Depends what
supposed to
justice
be,
is.
okay? You're supposed to be innocent until proven guilty, right? So there is a claim that they are innocent.
Man, have you seen the Japanese?
But we
justice system?
I was gonna say, we still have one of the better systems for that, but you assume innocence until proven guilty, so then we have a trial to test that hypothesis, right? And that's what we want to notice here.
Alright, so we read through this and look through the two different hypotheses. We have a null and an alternative, so read through, try to identify the differences.
So I'm just gonna make this a little bit bigger. And we'll get blurry.
So what's the difference between null and alternative?
The nose the initial.
Yeah. The null is like the default, the alternative is what you're trying to prove.
Okay. Shannon, do you have anything to add to that language?
Be careful in the AP world, we never prove anything.
Find evidence.
We find evidence and we conclude, but is anything 100%?
No.
No, right? So be careful with your language and be aware that we are trying, it's a claim we are trying to find evidence for. We can't prove it, but essentially, think about it again, going back to that idea of a trial. We don't prove someone is guilty, we don't prove someone is innocent, but we look at the evidence to conclude, is there enough evidence to think they're guilty, or do we not have enough evidence, and so we say they are not guilty. Notice that's the same language we'll use in AP. We'll never say someone's innocent. We'll never say that the null hypothesis is true. Either we have enough evidence to reject the null hypothesis, believe it's guilty, or we don't have enough evidence to reject the null hypothesis.
I think sometimes you can prove someone's guilty.
It's a dangerous idea, and I will say this in the AP world, you
I
cannot.
mean, not in the AP world, obviously.
Okay.
if you catch someone in the act, it's pretty obvious, but.
Alright, so with those alternative hypotheses, we have one-sided and two-sided.
So is this type 1, type 2, or is that?
No, type 1 and type 2 are types of errors.
Alright.
We'll talk about those types of errors early next week.
So type 1 is just states whether it's going to be greater than or less than the null. And type 2 is just stating whether it's going to be different from the null. So either less than or greater than.
And so that's where that not equal to shows up. By the way, guys, you'll have notes pages that should either go in the notes pages or in the fair model somewhere. See a lot of not writing is my point with that. But you can make that choice, but that's a dangerous choice to make. So hold on 1 second with that, 'cause I'm gonna show girls the details. Specifically two-sided. So, if you believe less than or greater than, that's that one-sided. That is not equal to, it's two-sided. But I tell you what, someone should be asking questions right about now.
What if we're just all really smart? I'm just trying to read it, to be honest.
So like, why would we ever use a two-sided?
It's a great question, but there's a more fundamental question you should be asking.
Is this on the test?
No.
What's the difference between?
Will I ever use this in the real world?
There's something else I'm thinking, guys, one-sided and two-sided of what?
Of the null hypothesis.
Of the null, right?
What does that mean though?
Like it's greater than or less than the claimed value.
But like how, when you collect data, right,
Yeah.
you're only gonna get one side of the null hypothesis, right?
Yeah.
Right.
So where are we talking about
It's like
one-sided and
one side
two-sided?
Of it, like, of a value, I guess.
Okay, of a graph, okay, what graph?
The normal distribution.
The normal distribution, right here. With this, right? With this, we only look, how many tails did we look at? One tail, so that was one or two-sided. That was one-sided, right? But if I were to just say, hey, I doubt their claim, not just that I think it's less than, but I doubt their claim in general, then I could have gotten a test statistic on the left side or on the right side. And so I would actually do the same exact z-score on the right-hand side. So what would happen to my area? Notice I don't actually have that value, but I am doing a second tail at the same exact z-score, just the positive. So this is a positive z-score, this is a negative z-score. What's going to happen to my p-value? It's going to double, right? I got double the amount, right? So the difference between a one-sided and a two-sided is just saying, hey, I don't believe this to be true. And then you would end up doubling that. And then some people were asking, well, why would you ever say I don't believe it? Well, if you haven't collected any data whatsoever, do you have an indication one way or the other? So your null hypothesis in that case a lot of times would be that it's not equal to. Okay? And so it depends on the context. But just so you're aware, you need to know the one-sided versus two-sided. That doesn't show up as much on the free response, but it does show up on the multiple choice portion of the AP exam pretty regularly, where you have to recognize, do I need one side or do I need both sides, because one will be double the area of the other. Does that make sense? So pay attention to that detail. Make sure you understand one-sided versus two-sided. So when we say one-sided, it's how many tails? One tail. And we won't actually have that second z-score, but we just double the area for the positive and the negative version of it. Yes. Save the slides.
Alright, so we talked about this a little bit. What is a p-value? What was our p-value for the 1 and 6 one?
Basically the likelihood of getting certain range of probabilities with, like in a sample.
So it's the likelihood of getting what?
The value or more extreme.
Mm-hmm. The likelihood. Okay, what were you saying instead of getting? Or is getting a statistical word?
Say that one more time.
So like the likelihood is getting a mathematical, like a.
Yeah,
correct
we usually say obtaining that statistic. Just want you to realize, Deacon, you and everyone in here is taking an AP class. Crap, my bad. Hey, really quick note, Mr. Arliss is writing it out verbally, but this is a great way to think about it that I had not seen until recently. It's the probability of getting that statistic or more extreme given what? That the P was true, that the null hypothesis
We gotta
is
stay
true.
here for a little bit. Okay.
So it's the probability of getting that statistic or a more extreme statistic given the null hypothesis is true. Hey guys, just so you know, my goal is to test on this before Good Friday. So we're going to move quickly Monday through Wednesday. Yeah, a week from today. Oh, y'all didn't type it.